Welcome. Today we're going to be taking a look at the scalar subqueries, aka a subquery that can give us just a single answer. The definition of a scalar subquery is any subquery that gives you exactly a single value. That means one row and one column, so it's just a single cell that gives you back for the table results that come back from it. This is often achieved through the result of an average, sum, min, or max use of an aggregate function because those give you always exactly one value back from that. And the results of those scalar subqueries can be paired either with equality or relational operators because it gives you a single value. So it can use any of those operators listed below to actually compare that result because it gives you a single thing right back from that. Now, why would we want to use a scalar subquery? Well, one of the biggest reasons we want to use a scalar subquery is that hard-coding values in your query itself is a really bad idea. You don't want to hard-code some magic number in there because you don't know if that number is going to change, or especially if it's dependent on data that's actually existing in your database, you don't want to have that hard-coded in there. You want to actually have that generated by the dynamic values your database is using. So we don't want to hard-code that. So instead we use a scalar subquery to extract that value directly from it. And we can match those calculated values very easily by matching the calculated value instead of matching that equal value or that individual hard-coded magic value right there. And this also allows for more complex queries over time because as you work in generating these large queries you can work with, perhaps you can save that query, use it as a named query in another query, or go back and re-reference it later on because you've got that information you can generate and calculate over time and get you that information you need to actually solve that problem. So let's take a look at the structure of that scalar subquery. So as you can see right here, I have a scalar subquery in my where clause, and so I'm going to have the select average of some field or max of some other field or something like that from some table. And so I'm going to grab that individual value and I'm matching against the field in the outer query. And so I'm replacing that calculated value that would be some field equals, let's say 100, with the results of that average function, so I can actually get the value I'm looking for more programmatically and that it will be updated over time, even if I add more rows to my database or remove rows from my database, because I'm matching the values that are calculated from that. It also keeps it in line with the KISS principle because we want to make sure that we have the most simple structure possible over time, because when we come back to it and look at it later on, we know why we're getting that answer, rather than why do I have 4003 here? Why is that number there? But by having a query here as an answer, I can actually read the logic of the query again and come back to it and understand what I'm doing. So we want to demonstrate the zip codes that are more than the average zip codes. First we want to find what the average of the zip codes are. Then we write the query that will get the zip codes that are greater than the average for verification, making sure we have the right answer. And then we'll combine those queries together to get the actual result we're looking for and have a better query overall. So we have our inner query and our outer query. So in my inner query, I'm going to find the average zip code. So I select average in zip.zip from average zip from zip code in zip. And my outer query is selecting out.zip, zip code out, where out.zip is greater than that hard-coded value. So I have that hard-coded average I've calculated returned earlier, so I have that information. And then I'm going to go ahead and combine that query together. So I'm selecting my out.zip from zip code out, where out.zip is greater than that calculated average. So I'm able to actually grab that information from the query, and no matter how many zip codes I add in or out of that database, I'm going to have the correct information. So I always get the zip codes that are greater than the average without having to worry about some hard-coded value locking my data out. And so it's a greater way to have that happen. And I can explain this because the information that's enclosed in the logic doesn't have magic numbers coded in here, so I know exactly what the kind of data I'm getting for as I just read the query itself and the English language behind it. Now, some of the key ideas we have when we're looking for this. When we're looking for a scalar value, we're looking to design a single solitary value. So what is the single answer I'm looking for? A scalar subquery really fits quite nicely into the where clause because it's like, oh, here's how I can compare against a single value. Great for restricting results on a query. I can also use this in the select clause for immediate use. If I want to say, for example, calculate some individual value and put it right there inside every row of my query, my select clause is a great space for that. Take a look at my video on using correlated subqueries to do even more examples with this because they have great examples for that too. It's also very easy to combine a subquery on the results with this using an and or, so I can have multiple subqueries combining results and grabbing those values out of that. And so it's a great way we can do even more with this subquery and get a lot of information out of this. So I hope this is a helpful way to review how to do a scalar subquery to get a single value and how you can use it as a sample query in your database. Hope this is helpful for you. Cheers, see you next time, and have a good day. Bye-bye.